video, we'll talk through the formula and equations topic from National 5 Chemistry Unit 1. By the end of this video, you should be able to write word equations, be able to write a chemical formula, and be able to write chemical equations. Starting off with word equations first, this is just a way of expressing what happens in a chemical reaction using words. We're given a description of a chemical reaction. In this case, the glucose in our body is joining with the oxygen taken from the air to produce water vapor and carbon dioxide, which we breathe out. We first would find out our reactants, which are the chemicals we have at the start, and then identify our products, which we have at the end. Once we have done that, we can then just put our reactants at the beginning of our equation, the products at the end, and we use an arrow in between the two sides. Type of question that you could be given, they might give you information about a reaction that's happening and ask you to create a word equation based on the information you see. We've got our starches reacting with water to produce glucose, which means that starch and water go before the arrow and glucose goes at the end of the arrow. When we start talking about chemical equations, we're going to be using chemical formula to represent different chemicals. For example, sodium can be represented as Na and water can be represented as H2O. The numbers should be subscript, and we've got our capital letters from the symbols where needed. Chemical equation is the chemical reaction being expressed by these formulae. Depending on whether we have an element or a compound, we will find the formula in different ways. If we find a chemical's name appears exactly in the periodic table, we've got an element. Compounds can have different endings to their names. If we have a compound ending in "ide", this will most probably contain two elements. Strontium chloride contains strontium and chlorine. If we have the ending "ate" or "ite", this indicates that oxygen is present as a third element within that compound. Sodium carbonate will contain sodium, carbon, and oxygen. In order to find out what formula we use to represent a particular chemical, we can use this flowchart that we'll hopefully get familiar with and be able to use from the top of our head. If we've got sodium, sodium is an element in the periodic table. Next, we need to consider if the chemical is a diatomic element. There are 7 diatomic elements that we should know about. We have hydrogen, iodine, nitrogen, fluorine, oxygen, chlorine, and bromine. Another way you can possibly remember them is by Hinn-Fockelbra, or you may have a different way of remembering which ones are diatomic. Sodium is not diatomic, so we just write the formula as the symbol in the periodic table, which is Na. If we look at nitrogen, again, we have got an element. We have this time got one of our diatomic elements, which means we're going to write it as N2. When it comes to compounds, we're going to go down to the right-hand side, and we're looking now at prefixes. Prefixes are the beginnings of the names, which tell us how many of each atom there is in a formula. And this will allow us to write the chemical equation straight away. If we had carbon monoxide, that means we've got one oxygen, so we have CO. Sulfur dioxide means there's 2 oxygens, so SO2. If we had phosphorus trihydride, that's 3 hydrogens, so PH3. Carbon tetrachloride means it's CCl4. And vanadium pentoxide means we've got 5 oxygens, so VO5. Going back to carbon monoxide, the name does tell us what we've got, and our formula would be written as CO. For a chemical such as carbon hydride, which is not an element, but its name does not tell us how many of each atom there is present in it, we'll have to use the valency crossover method. Our valency tells us how many bonds a particular atom will make, and it is related to the group the element is in. Group 1 makes 1 bond, Group 2 makes 2 bonds, Group 3 makes 3 bonds, Group 4 makes 4 bonds, Group 5 will make 3, Group 6 will make 2 bonds, 7 will make 1, and Group 8 will not bond because that's our noble gases, which are very unreactive elements. Using the crossover method, the first thing that we would do is write down the symbols we have for each part of our compound. We would find out which group it's in and therefore how many bonds it's going to make. In this case, we have group 4 for carbon, which makes 4 bonds, and group 1 for hydrogen, which makes 1 bond. You'd look and see if we could cancel these numbers down, if we can simplify them, which we cannot, and then we swap them over. And we use the numbers at the bottom here, so our swapped over numbers, and this tells me that I've got 1 carbon and 4 hydrogens written as CH4. If we had something like nitrogen bromide, write down our symbols. Nitrogen is in group 3, makes 3 bonds. Bromine is in group 7, and it's going to make 1 bond. Check if we cancel, which we cannot. Swap them over, and this gives us NBr3. There are times when we're going to be involving transition metals, and the question will tell you how many bonds a particular chemical will make. This is done in Roman numerals in brackets between the two words. We've got our copper and our oxygen. Copper makes 1 bond because we've got a 1 in Roman numerals in brackets. Oxygen is in group 6, so makes 2 bonds. Cannot cancel this down, so when we swap them over, we end up with Cu2 and O. If we have something like tin 4 oxide, this tells us that our tin is going to make 4 bonds. Oxygen is in group 6, so makes 2 bonds. We can cancel it down this time. Then we swap them over, giving us SnO2. There will be some questions which involve groups of atoms, which we can find on page 8 of the data booklet. And this one has dichromate in the question. We start off with our symbols. And the way I would do it would be I would ignore at the moment the 2 minus charge on it. We don't need to worry about that unless it talks about ionic formula. What the 2 minus does tell us, however, is that this dichromate will make 2 bonds. Lithium is in group 1, therefore it makes 1 bond. When we look to cancel it down, we cannot. Swap them over, and this gives us Li2, then Cr2O7. When we look at our carbonate example, we've got Al and CO3. Aluminium's in group 3, so makes 3 bonds. And the carbonate with the 2 minus charge is going to make 2 bonds. We can then swap them over. When we have multiples of a group ion, in this case we're going to have 3 CO3s, we're going to use brackets to separate them out. We have Al2, bracket off the CO3, and we've got 3 of them because we've swapped over the valencies in the question. If we were then going to put all of this together, we have carbon monoxide, which is not an element, but does have prefixes. We have oxygen, which is an element and it's diatomic. And carbon dioxide is not an element and does tell us the formula. And we get that CO plus O2 reacts to give CO2. Next one to look at, we have zinc and copper 2 sulfate coming together to form copper and zinc 2 sulfate. Our zinc and our copper are both elements which are not diatomic. They will just be written as their symbols in the periodic table, whereas we'd need to look at the valency crossover for copper sulfate and zinc sulfate. When we end up going through this, we'll get Zn plus CuSO4 reacts to give Cu plus ZnSO4. In terms of the types of questions you could be asked about, they could give you a formula and ask you to work out the name of the particular compound in question. In this question, we're working backwards from a formula. So the first thing I would do is write down my symbols for the 2 parts and also what I've got at the very end. The fact that it's VO2 tells me that after the valencies have been swapped, we end up with a 1 on the left and a 2 on the right. The data booklet tells us for oxygen, it's in group 6, so makes 2 bonds, and our vanadium we're not too sure about. What this means is that once we've swapped over our oxygen's valency, we should end up with a 2 associated with the vanadium, with the V which we don't have. The only way that this can work out is if we had a 4 for our vanadium, this would cancel down to give us our 1 and our 2, which show up in the formula. That means we must have vanadium 4 oxide, which is answer B. You could just be asked to write the formula for a particular chemical. We'll go through our valency crossover steps with hydroxide and aluminium. Aluminium in group 3 makes 3 bonds. Our hydroxide has a 1- charge, so makes one bond. Swap them over, and we would write Al, bracket off the OH, with a 3 after it. This type of question, we're putting together everything we've talked about throughout this video. We're told that in some types of airbags, electrical energy causes sodium azide to decompose, producing sodium metal and nitrogen gas. We're asked for our formula equation. I would start off by thinking about simplifying the statement at the top, where we've got sodium azide as the reactant, and sodium and nitrogen are going to be our products that are made. This gives us a word equation of sodium azide reacts to give sodium plus nitrogen. We can then use the formula given in the question. Sodium is an element, which will be Na. Nitrogen is a diatomic element, therefore would be N2, giving us our final answer. Hopefully by the end of this video, you are now more confident in writing word equations, being able to write chemical formula, and also being able to write chemical equations. Thank you for watching. Goodbye.